Hello and Assalamu alaikum. My name is Fakisha, and in this video, we will be discussing some questions from our assignment. So in this first video, in this first simulation, here we have AtMega 2056. Sorry. So we have AtMega 2560. So what we are doing over here is that stop the simulation. So over here I have to perform some operation that are OR operation and operation, and I have to call this operation by their hex, by the code program I have made. And so in that program I have dedicated each hex number to or AND operation, or NAND, NOR, XOR, XNOR. So these are 10 operations. So for 1 and 2, that are the in binary and hex, that is 1 and 10. So for that I have only to display my output. So if I simulate over here, so my simulation is running. So if I do 1 over here, so if I give any number, it will give me in binary, in decimal over here. If I give in binary, it displays me in decimal. So similar is the operation if I give 2 over here input, and if I give input over here, any input over here, it displays me that number in hexadecimal. So in order to perform addition function, we have to give 43 in hexadecimal. So if I this into this and 3 and this 4, so this is the 43. So this and I'm giving 8 over here, so it will gonna add 4 and 8 and display from my the output, which is not attached over here. So similarly, in our next case, if I want to apply any other function that is not function, so I have to do 0, 0, 1, and then I have to do 0, 0. So I was to perform a not, so 0, 1, 1 and 0, 1, 1 and 0, 0, 1, 1. So these last two. So this will give me not is 33. So if I do any other input over here, so it will perform an output, or to not function, it will not it will provide a complement of that. So if I have to perform XNOR, so it will be X 1, 0, 1, 1, 0, 1, and that is 0, 0, 1, 1. So that's just the same from onward. So this is 53. So if I have to perform 20, if I have performed minus, I will just give 0, 1, and I think 0, 1. So 0, 1, if I give it. So in this way, actually, this program is working, that we are giving the input from port C and giving the input of any other number from port B, and we are getting the output from port D. So if I move on to our next program, stop the simulation. So here I have a second project which has a keyboard and IC of that converts 8-bit into 4-bit. That is actually decoding. That is have 4922 IC. So there are actually three 7-segment displays. So what we are actually doing over here is that we have to perform addition and subtraction. So I will give addition from this keyboard, and then we will get that output over here. So actually this is not getting a right signal from the output over here. So I have made some changing in the code that will decode our message inside this AtMega 328p, and will display our output. So if I perform addition, if I do 1, so it is giving some wrong thing. It will be all right over here, and it will get away 1 over here. So we are getting 1 over here, and if I do plus, so it will take some time and make a change. As I've made the change over here, I do 1 plus 1, that is simple, and that will remain 2. So it's actually making 3, which is, if I do again plus, it is adding again into 4, so it is increasing. So if I want to do a subtraction, so if I want to do subtraction, so I make 6 over here, I get 6 on the output, minus, so I perform 6 minus 3 over here, that it gives me 3. If I perform minus again, I do minus. So if I run again only, so if I simulate it again, I give it, this time I gave him 4, right? 4, we do 4 minus 2 this time. So it is being converted in AtMega 328p. So I get 4. If I minus it, and then minus 2 from it, I should get 2 over here. So I'm getting 2 on my output. So in this way, our simulation is working rightly. I will be sharing my program in the assignment. So that was it from these videos. Thank you very much.